Hi everyone, and welcome to part 2 of derivatives of exponential and logarithmic functions. In this video, we're going to be looking at the derivative of natural log functions. So you'll see that we have this formula down here. The derivative of the natural log of x is 1 over x. Okay, now sometimes you'll see this with absolute values around it, but basically it's going to give you the same formula. So you'll see it sometimes with the absolute value here. Sometimes you'll see the absolute value down here, but it's still the same formula. So I just kind of left those off here. So the derivative of the natural log of x. Let's take a look at some examples of that. And I actually have 3 different examples because a few of them have some interesting things in them. You may have forgotten the properties of logarithms, where you can change multiplication into addition, you can change division into subtraction. Those are things that you might want to review before going into your homework, because sometimes we need to simplify before we're allowed to do our derivative. So just be careful about that. Okay, so in the first example we're going to do, we have the natural log of x cubed plus 1, and we need to find its derivative. Now notice there's an outside function, a natural log, and an inside function, x cubed plus 1. So we're going to need to use the chain rule. I'm going to let u equal x cubed plus 1, and I'm going to let y equal the natural log of u. Now we'll find our derivatives. The power rule here is going to give 3x squared, and the 1 is going to disappear because it's a constant, and the derivative of a constant is 0. Over here, I'm going to apply my formula. The natural log of x equals 1 over x. So in this case, I'm going to have the natural log of u equals 1 over u. Now what I'm going to do is multiply them together. I have 3x squared times 1 over u. I need to simplify. So multiply the numerators, multiply the denominators, and I need to replace u with what it was. So this is going to come out to be 3x squared over x cubed plus 1. And that is my derivative in this case. Okay, so let's do the next example. In that example, I have the natural log of sine x. And again, I have an outside function and an inside function. So this is the chain rule. So I'm going to make u equals sine x, and I'm going to let f of x equal the natural log of u. Now I'll do my derivatives. The derivative of sine is cosine, and the derivative of the natural log of u is 1 over u. I need to multiply these together. I should replace u with what it was. And then I notice that this can be simplified. Cosine over sine is cotangent. So that is my final answer here. So always look out when you're doing trig functions for some of those trig identities. And that's why we spent so much time on them last year in pre-calc. I know they might not have been everybody's favorite thing, but they are very helpful when you're trying to simplify. Okay, so 2 more examples and then we're done. In example 7, we have f of x equals the square root of the natural log of x. Again, we have an outside function and an inside function. Now, I'm going to change this to raising to a 1/2 power, and my inside function is going to be the natural log of x. So I'm going to let u equal the natural log of x, and f of x is going to equal u to the 1/2 power. Okay? To find my derivative here, I'm just going to do the derivative of u is 1 over x, using this property here. Over here, I need to use the power rule, which means bring the power to the front and go down by 1 on the power. Okay, now I'll multiply my 2 derivatives together. Okay, I need to replace my u with what it was, and I should simplify this power. So what's going to happen, 1 over x times 1 over 2 is 1 over 2x. This is going to the denominator, and it's a square root, and the u gets replaced with the natural log of x. Okay, so that's the answer to my example 7. Now for our last example, and this is the tricky one. In this one, they've done the natural log of a fraction. Now, if I really wanted to, I could use the quotient rule on this, but the quotient rule is kind of complicated, hard to remember. So what I'm going to do is I'm actually going to try and simplify this using the laws of logarithms. The natural log of a quotient is really the natural log of the numerator minus the natural log of the denominator. And what I'm going to do is I'm going to change this square root into a fractional power. Now, this fractional power, again, using the laws of logarithms, can get moved to the front of this natural log. So what I really have that I'm doing the derivative of is the natural log of x plus 1 minus 1/2 times the natural log of x minus 2. And now, one of the properties of derivatives is that I can do the derivative of this first part minus the derivative of this second part. So I can do them separately, and that's actually much easier to do. So looking at the first part, I have an inside function and an outside function. So what I'm going to do is make u equal the inside function, and the outside function is going to be the natural log of u. I'll do my derivatives. The derivative of this is just 1. The derivative of this is 1 over u. I multiply these together. 1 times 1 over u is just 1 over u. And then I have to put in the u that I had. So it's 1 over x plus 1. Now let's look at this other part. Okay, my inside function, I'll call it v, is x minus 2. My outside function, this constant just gets multiplied at the end because it's a constant. So my outside function is going to be the natural log of v. The derivative of this is just 1. The derivative of this is going to be 1 over v. I multiply them together. Don't forget about the 1/2 that used to be there. And then I replace my v with what it's equal to, x minus 2. So it's 1/2 times 1 over x minus 2. And these are subtracted. Now I can distribute in my 2. I can get common denominators and combine my two fractions. Personally, I would just distribute the 2 and just leave it as this. So that is the final answer in this. Okay, so that's it for this lesson. Now notice I combined a few of the different lessons. I took the derivatives from lessons 6.2, 6.3, and 6.4, and I put them all together. Next time we're going to be talking about the integrals from 6.2, 6.3, and 6.4. So let me know if you have any questions, and I'll talk to you soon.